Hello everyone, myself Kirtana and our team members are Uma Mahesh, Venkatesh and Spurti. Welcome to our project presentation on the California house price prediction. In this project, we use machine learning to predict house prices in California using two popular algorithms, linear regression and decision tree regressor. Let's begin by understanding the dataset we are working with. We use the California housing dataset, which is available in the Scikit-learn datasets model. This dataset includes information collected from the 1990 California census with the features like median income in the block, median house age in the block, average number of rooms per house, total population in the block, average occupancy per household, latitude and longitude like geographical coordinates. The target variables is median house value, which we have scaled by multiplying with 1 lakh to represent actual currency value. The dataset contains 20,640 entries, all with valid and non-null values. Let's take a look at the output of define head, which shows the first records. You can see how each row represents different locality with all the features and the corresponding house price. Then we used define.info and describe to get a summary of the data. This helped us understand that median income values range from 0.49 to 15 and house prices varies from 14,999 to 5 lakh, indicating a widespread of income and housing value. Next, will continued by Spurti.
Hello everyone. I am going to explain about data splitting and model training. Now that we have our data set ready and the next step is splitting the data into training and testing sets. We use a train dash tested split from sklearn dot model dash selection to split the features variable x and target variable y with a test size of 20%, meaning 80% data is used for training and 20% for testing. After splitting the data, we implemented linear regression. Linear regression is a supervised learning algorithm that finds the best fit straight line by minimizing the error between actual and predicted values. Next, we created a linear regression model, training it using dot fit, and then it predicted to the house prices using predict. Next, similarly, we used a decision tree regressor, which is a tree based model that splits the dataset into smaller and smaller parts based on feature values and makes prediction in a leaf nodes. Next, we trained the decision trees regressions with a fixed random state to ensure reproducibility. At this point, we have predictions from both models and we are ready to evaluate their performance. Next part will continue by Venkatesh.
Hello everyone. Now let's evaluate how well both model perform. For this we use two evaluation metrics, mean squared error and mean absolute error. Mean squared error which measures the average of the square of the errors. Mean absolute error which gives the average of absolute difference between predicted and actual values. For linear regression and decision tree regressor, the output which comes larger, it is the best part of the to predict house prices. This result clearly shows that decision tree model performs better as both its MSC and MAE are lower. Next, we visualize the prediction versus actual prices using Seaborn's scatter plots. On the left, we see linear regression predictions. The scatter plots shows a diagonal trends, but there's noticeable deviations. On the right, the decision tree scatter plots appears more clustered along the diagonally, indicating better prediction accuracies. This plot gives us as a visual representations of how closely the predicted prices matches the actual price. Next part will be explained by Umamesh.
In conclusion, both models were successfully predicting house prices, but decision tree are the better performed better than linear regression in both MSC and MAE. However, it's important note that linear regression is a simpler and fast, good for quick prediction when interpretability method. Decision tree, while more accurate here, you can overfit the may require turning techniques like methods for better generalization. In real world scenarios, predicting house prices is crucial for real estate companies for fair market values, buyers and sellers, negotiable efficiency, governments of plan urban development. In future, we can improve this project by adding more features like distance, city centers, schools, ratings, etc. Thank you.